All right, let's see. We've got just a few little things left before the course wraps up. Um, One of those is I'm going to talk about fasteners today. So sometimes you want to 3D print something and have it be a little bit more functional. And maybe part of that function means that you want to be able to bolt things together, fasten things together versus like gluing or or just printing it as a whole part or something like that. So you want to bolt on a cover, or you want to bolt two pieces together. You want to fasten them together somehow, and it's still a 3D printed part. So we're going to talk about how you can mix traditional hardware, nuts and bolts and screws and things like that, with your 3D printed parts in a useful way. So I've got a couple. Let's see here. I got a couple of samples of different things here. So you got a bolt with some nuts. You've got a screw with what's called a threaded insert. So this little part will come off of here. Well, I screwed it on there further than I thought. And it has, oh wow, let's zoom in on those. Those are really tiny. So this brass piece has threads inside of it, and you can insert that into your part. These are not specific to 3D printing. These existed before 3D printing, but they can be used as a way to put metal threads into a plastic part. We've got some just really coarse. This is just a wood screw. Here, I've got a sample of just a regular machine screw. So this one, we're going to try and just print the threads. Design. I'm going to use Fusion 360 today. These same processes would work in any of your CAD modeling packages, SolidWorks, whatever. I'm going to use Fusion 360 since you can get a license for it for, I believe you can still get a free license. If not, then there's a relatively cheap license. But there are free CAD modeling packages out there, FreeCAD, one of them, that can do these kind of things. I'm just going to use Fusion today. We've got some screws that are specifically made for plastic. So they usually look a lot like the wood screws, maybe slightly less pitch, so slant. Well, pitch is a different word in screw threads, but in screw thread terms, pitch means the distance between adjacent threads, and I was actually referring to the slope of the threads there, but it still means roughly the same thing. So you could just use really coarse threads. There are some that are plastic threads. Not the plastic. The screw is not plastic, but it's meant to bite into plastic holes. We've got a little set here of just a tiny, probably a M3. So M means it's a metric screw. 3 means it's 3mm major diameter. So if you were to measure the outside of the threads, well, I guess we could do that. I've got my calipers right here. So calipers are going to be handy for today, because I haven't gone ahead of time and measured stuff. So let's see. So 2.76. I would assume that's a 3 M3. Oh well, you know what? This may not be metric actually. This could be a US thread type of screw. So this might be a number. Oh, I don't remember. Number 6 maybe. I don't know. We'd have to look it up. We can do that in a minute if we want to. I'm not particularly interested in exactly what size that one is. This one, we're going to do what's called a slot, where we can slot in the nut and then use it kind of as a captured nut type of thing, but we can do it after the print. So we're going to go through several of these, how you might use these different techniques to add metal fasteners to your 3D print. So let's and I don't know if we'll get to actually do all of these or not. It depends on how fast we can print things, but I'm going to model them in 360, or well, in Fusion. I think it used to be called Fusion 360, and they have rebranded to just Fusion. So I might say several different names for what I'm going to use here, but I'm going to use this piece of software, which looks like it is running here. So let's kind of get it on the screen in a useful way. There we go. Something like that. And then let's just start working on building out one test rig that can hold a bunch of these different things. Now I have found some of these. I think this one, yeah. So this is from Formlabs. I think I put a link to this site in the description. Maybe not, but you could look at. It's just Formlabs adding screw threads. So this is kind of a write-up that they did. Now Formlabs is a resin-based printer, so it's a little bit different. I actually think this might be a SLS print. I'm not sure what. Oh yeah. So I think this might be a SLS print, but the idea is the same. So what this is kind of their little test print where you've got a variety of heat set inserts. You've got some captured nuts. You've got just a hole that you self-tap the screw into. You've got some printed threads. You've got these little T-slots on the side here where a nut slides in and kind of gets captured. And then it's a hole for the bolt or screw to go through. And so it kind of goes through each of these, what their benefits are, what the downsides are, and kind of shows you how you might. It doesn't show you how to design them, but it shows you what they look like. And they're pretty straightforward to design. So there's not a lot of complications on actually designing any of these fixtures. The one that they don't have in this little test rig anyway is this version of the nut. I called it a captured nut, but this is more like a press fit nut. So sometimes this will work fine, where you just leave a hex. This is a hexagon shaped nut, so you leave a hex shaped hole and you press the nut into that hole and it's fine. Sometimes you want it completely captured because maybe you don't want this to fall out ever or whatever, and so that's a little bit more complicated, but only in the sense that you have to pause the print midway through somehow to actually insert those nuts and then print over the top of them. So that's a slightly more complicated way to do it. It ends up sort of like these. The downside to these here, they are captured in most directions, but they can slide out the side. So you can't put them in the very interior part without a long slot leading you down to them to drop the nut into. So we're just going to go through and we'll design some of these. I will say that it's probably best to print something like this. It doesn't have to be this particular one. I think I also put a link to this in the description. But all this is it's a part that's modeled with holes of specific sizes, and they're labeled here, and then you print them, and you can figure out, like, okay, I need a 3mm hole, but if I design a 3mm hole and actually print it, then it turns out that it's the one that's named 2.9. So it's kind of a tolerance grade of I made a specific size in my CAD package, but when I printed it, it came out a different size, either bigger or smaller. And so something like this can help you figure out, all right, if I want a hole that ends up exactly 4mm, then I need to design it at whatever. And it has to do with the tuning of your printer, your flow rate, your E-steps, all of these things that might affect the over or under extrusion of your walls of your print. So something like this, I have not printed one on this printer, so it's not available for us, so I'm just going to have to guess. But something like this would help if you find yourself always printing holes that need to be a particular size. You could make this with round holes, you could make it with hexagon holes if you wanted to do a tolerance for dropping in hex nuts or something like that. But these would be handy to do. So let's go back to Fusion. Let's go over here, and why don't we start with just a press fit hex nut. So I'm gonna build basically something a lot like what they have here. Some little box. I probably won't worry with the cavity here. I'll probably just make it more like a block, and we'll put a variety of these in it so that we can print and see how it works. And again, I don't know if we'll get to print today because I don't know how long it'll take to print. All right, so Fusion, wow, I'm turned all, let's see, let's go to the front view here so I know where I'm at. So that's the front view. Where's the top view? There we go. So there's our top plane. I'm just going to create a rectangle in here, and I don't want this to be too long because I would like to be able to print it today. So let's say that I should have had a ruler out here, but let's say that I want something in the range of 60 millimeters by 40, 60 by 40 millimeters. So the D key gets me to dimensions, and I'm already in millimeters. It showed millimeters on the little call out there, so that's probably a reasonable size. Let's go ahead and we could build in some of the shapes now, but let's go ahead and extrude this thing. Let's make it not very thick so that we again can print it faster. I think based on the size of the largest thing we need to insert, I think 15 millimeters will be a good thickness. So there's my little plane. Select it, E for extrude, 15 millimeters. There's our block. Okay. All right, and then we'll start adding our features into the top of this block. Okay. So let's create a sketch on the top surface here, and we will kind of start building in some of our shapes. So if we want to do the hex first, then I believe the hex nuts, the hex shapes, hex polygons in here are either made by an inscribed circle or a circumscribed circle or a edge length. Let's just do an edge length to start with, and we'll size it later. So I'm just going to measure, let's see, I'm actually at 0, and I'm going to measure one edge here somewhere around 7 millimeters. We'll call it 7. This is probably not a metric. Looking at it, I don't think this is a metric bolt anyway, but it'll be fine. All right, so we're going to create a polygon, and there's our 3 types of. We're just going to do the edge, and we'll put it somewhere out here. Let's make it. There we go. We can enter the number of sides. This is a hex nut, so we need 6 sides. And then let's kind of position it somewhere. So I'm going to dimension. Let's make that 10 millimeters, and then let's set it down 10. We could probably make it closer. We can change those later if we want to. And then what I'm actually going to do is I'm going to measure across the faces. So I'm going to measure like this, and that says it's 12.6 millimeters, more or less. I'm going to assume that my printer is probably going to, it'd be a worst case scenario to make the hole too small. Obviously, if I make it really large, then there's nothing to grab the edges of the hex nut, and it will just spin in the hole. So I do have to have some amount of tolerance. If the hole was slightly undersized, then I could press the nut into the hole and it would be okay with the cavity. So I'm gonna, it said, I've already forgotten, 2.6 was it? Or 2.7? 2.6. 12.6 rather. I'm gonna dimension across the flats here. Let's zoom in. And I'm gonna set it to, I don't know, 13 is probably too much. Let's do 12.8 millimeters across there, and see if that'll work. Now I'm getting kind of close to the edge here. Oh wait, hold up. You're not seeing what I'm doing. I just dimensioned across the flats. Now one thing that can happen, and I don't think it happened in this case, but it's possible that when you're moving the hex shape around, it gets twisted around. If you want it to stay a certain orientation, you can pick one of the sides and constrain it to be horizontal or vertical or whatever, and that will lock it to where it doesn't twist around on you, if you want that to happen. So there's that. Okay, so let's go ahead, let's do these one at a time. So I'll finish that, and then I can select it, E to extrude, and I can just go downwards, and I'm going to go down, roughly the height of the nut. So I don't want it to protrude past the face, so it says it's 6.8. Let's go down 7 millimeters and call that good. Oh, well, -7. There we go. So there's our little spot for the hex nut. You can go in and make tiny little fillets on these corners if you want to. I'm going to ignore that. It'll round them out a little bit anyway when I go to print, but I think we're okay there. All right, so that should give us a reasonable cavity to press in or drop in. I don't know. So it depends on what you want to do here. So if this is going to happen, if it's a press in after I have printed the part, I'm not interested in kind of making a captured nut, then it can press in. But if you're doing a drop in while it's printing, you want to print over the top of it, which is not what I designed here, but you want to do that, then it's better to do something where you can drop the nut in. You don't have to press it in, because this print needs to stay on your print bed so that you can keep everything lined up and pause the print, drop in the nut, and then finish the print. But if you're having to press the nut in there, then there's a good chance you're going to break something loose on the break the print loose from your printer, and then you'll not be able to finish it. So if you're doing a drop in while it's printing, make it a little larger. If you're doing a press, after the fact, then it's fine. You can make it a little bit smaller so there's a tight fit. Let's see what else we have. So that takes care of this guy, and we only did the press in version. We can do the captured one, but that'll take a little bit more on the slicing side because we have to pause our print. Let's do this one. So this one, I want to actually print the threads straight into the block. So the block itself has printed threads in there. That's one way that you could easily, you don't have to have any special hardware other than the screw itself. Generally with this, you want a machine screw. So a machine screw has these threads that are, more like, well, let's zoom, more like this one versus this one. So this is, well, all right, I'm pointing, it's hard to point. Let's get our blazing sword piece out here. So this guy is a coarse machine thread. So that means the threads are kind of spaced far apart, as opposed to one like this, where the threads are closer together. So that's a fine machine thread. For this purpose, when I want to print the threads directly on the part, the coarse is going to be better for me, because it'll give me a little more layers to actually work with when I want to print one type of screw thread. With these finer ones, I have to either use a really thin layer, or just realize that it's not going to be able to resolve the threads in the print. This one, or either of these two over here on the far edge, those are the coarse ones. The black one here, that one, is the one that's meant for plastic. This other one's actually meant for wood. Those, you could just screw them in. They're not called self-tapping, but essentially they would be self-tapping screws. Actually, this one might be, if I could. No, the self-tapping screws usually have the very end of them, or is a little tiny drill. Looks similar to the end of a drill bit. This one, these both would self-tap. Tap in this context means to cut threads into in this case, plastic. So let's just make these threads. So I do need to know what kind of threads these are in order to make them. And how you define threads are, you need the major diameter, which is the diameter across. If I measured this, so there's the major diameter, so I'm 6.22 millimeters. This is probably a US, so let's switch over to inch system here. 0.245, so that's a quarter. So this is a quarter, 1/4 of an inch, and then the other part is the pitch. So I need to know, in a US type of screw, I need to know how many threads are there per inch. In a metric type screw, like this black one over here, I need to know how many millimeters are there between adjacent screw threads. So this one, I'm pretty sure, is a US screw because it's a 1/4 inch, 0.245 versus 0.25. And I know that many of the common screw pitches for a quarter inch bolt, or screw in this case, is 20 threads per inch. So I'm expecting this to be 20 threads per inch. To figure out if that's true or not, I'm gonna measure out a 1/2 inch here, because the bolt's not or the screw is not a inch long, so I can't measure out. So there's point, I'm trying to get close there. There's 0.499. That's going to be close enough. I'm going to lock it down, and then I'm going to measure across here and count the number of threads. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think that was 10. So, and 10 in 1/2 inch would be 20 in 1 inch. So I'd have 20 threads per inch of screw. And so this would be called a 1/4 20. As they get smaller and smaller and smaller, like this guy, then you don't start talking about their actual diameter. They switch to a number system. And so you have to know that a number 8 goes with a whatever major diameter, which I don't know. You'd have to look it up. Metric ones would work the same way, except I measure the outer diameter in the metric system here. So this is an M5, 4.94 millimeters. So I'm measuring the major diameter here. So that would be an M5. And then for it, you determine the pitch by, trying to measure the distance between adjacent threads. Maybe you could do the similar thing where you measure a bunch of them. But that's one, I think, it's super tiny. I think it's about a millimeter. There are maybe 3 common spacings. I think one of them is a millimeter. Then maybe one of them is, maybe there's a smaller than a millimeter pitch, and then a larger than a millimeter. I don't know. But you would have to know the pitch of the thread. So let's go to Fusion and see how I'm going to deal with this. So for the 1/4 20 bolt, I keep calling it a bolt, but it's really a screw. So when it has a, this kind of cap head on it, and this one has a hex socket in there, that's really more of a screw, where this with a shank and a hex and a washer face down here, that's more of a bolt. Doesn't matter. They still do their jobs, no matter what you call them. But I'm dealing with a 1/4 20 screw. So I need to build, in my model here, a 1/4 inch hole. So I'm going to create let's do a sketch on this top surface. Get it kind of centered up here, and let's just put a hole. Let's line it up with that somewhere over here. D to dimension it. And these are millimeters, but I can tell it that I want 0.25 inches, and it'll convert it to millimeters for me. We'll finish that sketch. We will take this. Let's just make this go no, let's not make it go all the way through. Let's just drop it down some amount. I don't know. I think I made this 15 millimeters, so let's make it 10 millimeters. Oh, so I did positive 10, so I can go down here and edit that feature and change that to negative 10. There we go. Oh, but hold up. Edit the feature, and I want to cut over here. So I just kind of made it overlap itself, so I'm going to cut instead. There we have a hole. So now I have a hole, and the hole is basically the size of the major diameter. So if I just left it this way, then the screw would basically just drop in there. Maybe it'd grab a little bit, but it'd basically just drop in. So I want to put threads in here. So in my create menu, I have threads, and I pick what hole I want to add threads to. I actually want to model them. I don't want them to just be like a texture, so I want to model the threads in there. ISO metric, so that's the metric system. I want a ANSI United screw threads, so I want that. unified, not united, unified screw threads. And I want it to be, it's already set to a quarter. Actually, that's what I want. Quarter 20, so 20 is the threads per inch. UNC means the course series. There you can kind of see some fine and ultra fine and all of that, and you get higher and higher density of threads. So these are more and more threads per inch, but I measured mine, and I got quarter 20. And we don't need to know the class. Direction means, do I turn it, the normal way to screw it in, or the left-handed threads, and turning it the normal way actually backs it out. So I want the right-hand threads. So normally you don't have to worry with class and direction. You just got to figure out the right size. So we figured it out by using our calipers and measuring it, but there are screw gauges and thread profile tools that if you do this often, you would probably have those tools. But you can just measure them. So there, and now I've got a set of threads that are modeled in there. Like I've got actual threads inside there. If I didn't click the modeled button, it would just be a texture. I wouldn't have the actual geometry. Now, I don't know how accurate my printer is, so I don't know if these are going to be really tight or loose or anything. I think they'll be okay though, because if nothing else, I should be able to get the bolt to more or less, form these threads as it goes. Let's do one. So we've done this guy, and we've done this guy. Let's do this one with the heated insert. So how this will work is I'm just going to create a hole. The hole is going to be a little bit smaller than this brass insert, and I'm going to heat this up. I'm going to use a soldering iron and push it into that smaller sized hole, and these little ridges on the edge will grab a hold of the hole and provide you some torque resistance. So the key to these is figuring out how much smaller do you make the hole and still be able to force it in there without kind of like destroying everything. But the hole can't be too large, because then this doesn't actually, it just drops in the hole and it doesn't do anything. So it does have this I don't know, ferruled, this region with no ridges on it. I'm going to measure that in millimeters and see what that says. Again, I think these might be metric. So that is 6.2 millimeters. I'm going to make the hole 6 millimeters and see if that gives me enough clear bite. I don't actually know. So I'm going to do 6 millimeters. So this is just going to be create a sketch on this surface. Get it over here, and let's just drop a hole. Let's kind of line them all up here. And I'm just going to make this one D to dimension, and I'm just going to make it 6 millimeters. And then we'll finish. We'll take this, we'll extrude, and we'll go down -10. So that one looks, a little bit larger than the bolt. Let's see. That's probably reasonable. This might be a little bit large of a hole. I might need it to be slightly smaller. I am going to bet that someone out there has put a chart together of, for that particular size heated insert, use this size hole. I just didn't look for it. All right. So now we've got this guy ready. Let's just do one of these. So these, the idea is that I'm just going to make a hole that these are pretty sharp threads, and I think they can just cut their way into the plastic. So these are more, you can reuse them, but the other 3 that we've done so far are meant for, I plan to take this apart more than, once or twice. This one is, I need to screw it together, but I don't really plan on taking it apart very often. So this is a good option for that kind of scenario. To do this, so I had been measuring across the outside part and measuring the major diameter. But if you look, for these, you can kind of measure between the threads to the root diameter. And if you make the hole somewhere either that size, or another thing you could do is just take a good rule of thumb is take the major diameter and divide by 2 and make the hole that size. Either one of those approaches will get you pretty close on this. So I'm going to do the major diameter divided by 2. So it says it's 3.44, so I'm going to do half of that as my hole size. So we'll put that one down here in the bottom somewhere. So let's create a hole. Let's line it up. Oh wait, why are we not grabbing any of our features here? So I want to grab the center of this hex, but it's not like, it does grab that one. Maybe we can put it there. Maybe it'll grab the center of that line. There we go. I guess the hex doesn't have a center as far as Fusion is concerned. So we measured that this diameter was 3.44 of the major diameter. You can do math in here. So I'm going to do 3.44 millimeters divided by 2. And it'll size it for me. So you can do math in the equations that control your dimensions. So that looks really tiny. But let's do this. We'll extrude -10. And there's that little hole. Okay. So now we've got, and that'll work, which I think I measured this one, didn't I? So that'll work for this one. We've done this. Have we done all of them? I think we've done all of our, oh, no, we haven't done this one. So this one's a little different. The idea here is that I want to use this screw and this nut. But I don't want to push the nut into the plastic. Because I'm afraid what will happen is that being the size, this is really tiny, being that size, it'll probably not grab a hold very well. I'd have to have my tolerances very well tuned for it to grab a hold of the nut being that small. So instead, I want to create this kind of slot on the side. So I need to basically drill in a little slot into the side, and then I need to drill a hole for the screw to go through. So let's first see what is the face width, or not the face width, but the distance across the faces. So this distance, 6.24 millimeters. I have to be pretty close to that. Too narrow, and it's not going to slide in there very well. Much too wide, you know, a little bit too wide, and it's not going to grab a hold of anything. It's just going to spin in the hole and not do anything. So I need to be pretty close to 6.24 on my slot here. Let's put it on, let's put it on this front face. So we'll create on this front face, and we will create just a little rectangle somewhere. I don't know, it's not lined up with anything, so somewhere there. And we need to get these dimensions relatively tight. So this one, we measured 6.24. Let's do 6.3 millimeters. And then I didn't measure the thickness. Let me just do that real quick. 2.4. This one's not as important as far as capturing the nut inside there. 2.41. So let's do 2.5 in this direction. So there's our little slot that we want to drill into the part. And so one thing I'll run into here is the top surface here is going to be a bridge. Most printers are able to bridge, 6 millimeters pretty well. But if your printer, maybe that material or your cooling is not sufficient, then it's possible that this little bridge is going to sag a little bit. This is similar to, let me find one. This is similar to, when you print your Benchy, printing this bridge right here, right there. So if your Benchy came out and there's not a whole lot of sag across that front window, then you're probably okay with the little slot you want to print here. This particular Benchy doesn't look very saggy at all. Let's see if I have one that does have more sag. This one has a little more. So you can kind of see how this one across the front there is drooping down a little bit. That's probably not enough to create problems with our slot here, but if your printer isn't able to bridge too well, then you might have some issues with these slots. I don't think this is this is half the distance, or not even the whole distance that these little guys are. So I think this will be fine. So let's finish that sketch. I didn't bother to set a depth here. The screw is this long, but you would probably want to figure out how deep do you want this to be. So I'm going to extrude this guy, and I'm going to extrude him into our block, not that far. So the further you go, then obviously there's more bridging. It's going to bridge across, like horizontally in this view. But if I wanted the screw there, I'd probably go from the other side. Let's say that I want it, maybe in, we'll line it up with that other one there. So something like that. And we'll cut that out. And just now I need to put the hole in here. So we'll create on the top surface a hole. Now I'd like to reference the walls here, but I don't have a way to select them when I'm working on this top surface. You can, in your create menu here, you can project other lines that aren't part of the surface you're working on onto the surface just for the purpose of like measuring. So I'm going to project that. Let's see if I can get one of them. I want to project that line. Oh, it locked up on me. There it goes. and see how it put that little pink line on top. And I want to project that one. And maybe just to have it, that one back there. So I'm going to project those lines that I need to reference onto this top surface, so that I can be able to center up the hole where I want it. So now we can create our hole, and now I can select these lines, and I can maybe pick the center there, put the hole here. This one needs to be a clearance hole. So I'm going to measure the major diameter of this guy, and 2.71, and I'm going to make it a little bit larger than that. So diameter, well, that's quite a bit larger. Let's do 2.8. Should be fine. And then we will finish our sketch, and we'll take this surface, if I can get it, there we go, and extrude. This one we need to at least extrude down to here, but we probably should go the full 10 millimeters that we've been doing. The 10 is not magic, it's just the number I've been using. Just so it doesn't go through the bottom here, and it does give us some depth in these holes. So let's see. We've done one for that. I've lost the one that we just did. I don't know where it went, so I'll have to find it before we can actually assemble it. We've done this setup. We've done this, and oh, it's in the calipers. There we go. We've done that. So those are the main types that we might run into. Let's see if I left any off from. I made a list over here. Self-tapping, captured, T-slot, modeled, heat set. Yeah, I think we did most of them where you're including some kind of other fasteners. There are other ways to connect things, snap fits and all those kind of things. We were just doing actual fasteners. All right, so I think we've got some representative of all of these. So we probably did make it a little bit large. We could save some time. I don't even have anything over here, but we'll just slice it and see how long it's going to take. So I need to select everything. I think right click, save as mesh. I've got an option for 3MF and STL, binary and ASCII, and OBJ. 3MF will be fine. And that sounds good. And we'll save it. Let's save it to my computer so that it's not in the cloud here. This will be fastener test block. That sounds good. Okay. I've got Orca Slicer going here. So new project. This is for the Voron 0. That's the printer that I've got sitting over here. So that's the one we'll use. I do have the generic PLA. I never did do a flow test on this, so let's check what the flow rate is set at. It's at 98. That's the default. 98% flow ratio. That'll be fine. That would be advisable to do your calibrations beforehand so that you kind of know what tolerances you need. Let's bring in our part. So I'd saved it to the desktop, I think. There it is. I don't want it that orientation. I was planning on printing it. I don't want to auto orient. Let's just rotate manually. We need that one. There we go. So there's our little part. Now, one thing I should have done when I was designing the part, but we did it pretty quickly, was make sure that the depths and everything that I was dealing with, the heights of things, were an evenly divisible number by whatever my layer height was going to be. I want this one to print relatively fast, so I'm going to up the layer height. This printer has a 0.4 millimeter nozzle, so about as large as it's going to reliably print for me is 0.3 millimeters without some special tuning. Let's make the first layer also 0.3. Line width, it has a 0.4 millimeter nozzle, so that sounds fine. They've got a extra extrusion here on the first layer just to get it to stick down. That's probably fine. Those are all fine. Seam, we can have it on one of these corners and that will be fine. Here's that ironing. So if I were worried about the top surface quality, I could have it iron. I don't want to worry with that on this one. Let's go with strength. So strength does matter here because particularly on the hex captured nut or pressed in nut, I need some strength around there. So this is mainly going to be derived from the number of walls that I use. Currently I'm at 2 walls, 2 perimeters. That's not that many for actually getting strength around here. I don't want to add a lot of them because it's going to take even longer to print then. And I already don't think we'll have time to print it in class. But if I were printing a captured hex nut like this, I would probably do 4 walls around it just to give it some strength to resist the torque if I go and tighten whatever. Oh, you know what? I just realized I can't actually put a bolt in there because I didn't drill the hole all the way through. So I actually need to create on this surface a hole, and it's got the same problem of not wanting to pick up any of these lines here, so I need to project that line, and then I can create the hole. Oh, you know what? I need that corner too, so I can line it up in. Oh, there we go. We got that one. All right. So, and this was a 1/4 inch. So this also needs to be a clearance hole. So let's do 0.25, but let's do 2.7 inches. And then we will finish that, and we will make this a through hole, so it just goes all the way through everything. So now the actual bolt itself can go through there. Now let's extract this thing, save as a mesh, leave all our options the same as it was before. Let's do fastener test print, and let's change it out over here. So let's delete that one and add our new one. There we go. We will save those changes that I made so it stays with the 0.3 millimeter layer height. And then I think this button is lay on face, and I can just pick that. Okay. So I'm going to do 2 walls, even though normally I would do 4 walls here, particularly around the ones where it's biting into the material. So the hex, the threads, are the one where it's going to just bite its way through. I think that's this one. All right. But I'm going to do 2 for speed purposes. Let's do our first layer at 40. That's pretty slow, but that's okay. And then we are at 100 on these others, and that's probably okay. We don't need support, so we can turn that off. Maybe you want to decide on a brim or anything like that. I don't think I need any of those, although I don't know. Let's see, is it turned on? I think it's in others, isn't it? Brim is, let's do no brim. And then skirt loops, just you know, if that's the tracing around the outside, just to kind of purge the printer, make sure everything's working fine. So let's slice the plate and see how long we're looking at. It says 25 minutes, so technically we do have that much time left in class. I don't know if we'll get it in time or not, but let's kind of check out our layers here. I've got a gyroid infill going on, which is okay. There are those, where'd they go? There, those blue lines there. How do I get rid of this? That made it worse. I don't know how to hide that. Those blue lines, that's my, oh. So there is going to be a little problem right here. So these are fine. This bridging is fine, but here it has to bridge around a hole. So there's actually no place for these to end. So it's going to be messy right there. So if we wanted to address that, we could, but it's actually just we could put some support in there. Then you just got to figure out how you're going to get it out. I'm just going to let it print and let it be messy, but realize that that little area there is going to be a problem printing wise. Also look at our threads here that are modeled in. I've got a relatively thick layer height. Now these are pretty thick threads, so these threads are not going to be very well formed. If I were trying to get well formed threads to match up with the threads on the screw, then I need thinner layers or a really coarse threaded bolt. There are some that are even more coarse threaded than the 20 threads per inch. Then this is our heat set. Same thing with the heat set. I really would rather have more parameters around it to give something to melt the heat set into. All right. So I think the printer is going. I think I'm going to print. I think it's connected to it. So let's just upload and print, and we'll see if that actually works or not. I think it's on. Let's look at the yeah, it has it there. It's just trying to heat up the bed right now. Oh yeah, I did have it on PLA. So we'll give that a minute. Probably won't sit here the whole time it's printing, but while it's doing its thing, I do have a couple of other things to show you. So on those heat set inserts, here are, this is CNC Kitchen. You can get them Amazon, all over the places, but this site, this is from Stefan from his YouTube at CNC Kitchen. He has a company that sells these little bit. They're a little bit more expensive, but they have a little bit more bite to them than the cheaper versions. But what I wanted to show you here, though, is not the heat set inserts. There are tools like these tools that will work with soldering irons. He has a variety of different types of soldering irons. I'll show you some here in a minute. But if you do a lot of heat set inserts, so maybe you do want to print one of those Voron kits, they use a lot of heat set inserts. So if you're doing something where you're repeatedly doing this, then it might pay off to get some of the tools that actually match up with the heat set inserts. You don't have to have them. I've done plenty without any special tools, just a soldering iron, a cheap soldering iron, and they will work, but the tools do make it a nicer process. So I was just going to point out that they do make tools here. Let's see, here are some cheap tools like this, and then here, let's see if I can get it out of here. Here are some of the nicer tools. Now these two sets work on different types of soldering irons. So this set actually have screw threads in here that will match up with one of these style soldering irons. Let's see if I can get it out of my little case. It's all plugged up in here. You know, one of this kind where they use that sort of soldering tip. To match up, though, you do have to have one that has the matching screw thread. So, you know, this would go in here, and this would screw onto the end of there. And so that's one style. This style, I think I just got from Amazon. It matches more this kind of soldering iron where you've got the, oh wait, the whole thing's turning there, hold up. This is a cheapy one. You know, this sort of thing. So both of them are doing the same idea but with different tools. I don't know why that's turning on me. That doesn't seem like something I want to happen. But so these, this one is still a cheap soldering iron, but it does have some temperature control on how hot the tip gets. Generally with these, you want the tip pretty cold compared to what you normally are like soldering at or something, because the little heat set, it's going to absorb this heat and it's going to dump it into your plastic, and if this is too hot, it's basically just going to melt its way through your plastic. Our print has started over there and it looks fine, so we'll let it go for a little bit. So you do want something where you can control it down to pretty cold temperatures, you know, something that's not going to liquefy, what I guess it doesn't liquefy, but you know, really soften up the PLA or whatever material you're using, but it does get above the glass transition temperature. So you want a pretty low temperature. All right. Oh, these things, so you know, these are stepped so that they actually fit. One of these will fit into the diameter of the heat set. I guess it's that first one I used. And there's not a whole lot of wobble. If you just try putting this on like a regular soldering tip like this one, you know, which will work, but it's, you know, it's wobbly, and you can get the heat set into your part kind of crooked. So these do help out on getting the heat set to drop in more straight. They even have, I don't have, but they even have like little mini drill presses where it's, you know, dropping it perfectly perpendicular straight down. I've always had good enough luck just doing by hand. Let's see, so that's that. What else do I have up here? Oh, here's another thing. So if you do find, oh, I already showed you the hole gauge. If you do find yourself like wanting to make parts that are more functional, like they actually work and they're 3D printed, FDM 3D printed, there is a good channel. This channel, Slant 3D, they are a print farm, so they have, I don't know, 1,000 FDM printers or more. You can kind of see kind of their header up here, and it's just racks and racks and racks of custom, their version of FDM printers. But that's not the point. The point is their videos are usually, you know, best practices based on their experience. This guy's an engineer. Based on their experience of actually printing thousands of things, maybe millions of things, I don't know, at scale and in FDM. So there's all sorts of videos on, like, they probably have one for Fasteners, although they try to make everything FDM and not include mixed media. A lot of their prints are that way. You know, snap fits. Do you want to do a snap fit design? They give you some ideas on how to make better snap fits. You know, products that have sold. Let's see. You need to print a dome, but it's going to be ugly on the inside. There's some tips, and usually they're relatively like 5 to 10 minute long videos. You need to glue parts. They've got a video on that, so they're a pretty good resource. I did put their link in the description, I'm pretty sure, of just a variety of making functional FDM parts, and on the design side, not just on the print side, but on the actual design of the part to begin with. So they're a good resource for probably have something out there about a problem you're trying to solve, and they've already kind of addressed it at some level. All right, so printer's going over here if you can't hear it. Let's see if we can see it. He's upside down. Let's rotate around. This one? There he goes. So, I don't know what speed. We're printing at 100 millimeters per second there, so that's reasonable for a Voron. And it looks like it's doing okay. It's just PLA, and it looks like it's doing fine. But I don't think like I don't know that I want to just sit here. It's already 15% done, but I don't know if I want to just sit here and watch it print just so we can see the block that we have done. So we might have to use the block on Monday. I think we only have Monday and Wednesday left. I think that's the amount of courses, or maybe it's just Monday. Maybe Wednesday is just kind of the wrap-up day. I don't remember now. But I think I'll let this print. I will close down the stream, and we'll pick up Monday with at least actually using these inserts and everything so that you can see them, how they fit. I might have to reprint it if I've got my tolerances all messed up, but we'll find that out on Monday. All right, have a good weekend, and I will see you on Monday, and we'll be wrapping up the course next week.